If you're planting containers, let me ask you, what would you think of a setup that allows you to plant, water once, and then never have to water again until you harvest? I have some ideas that I want to share with you today surrounding planting pots that may make this possible. First, let's review some theory. We're going to look at three different types of pots. The first is a traditional pot. The second one has a water reservoir at the bottom. And the third one, which is the new twist on things, has no drainage holes. To talk about these things, I wanted you and I to do something a little fun, which is to become the water drop. So if you and I, we're going to become a water drop for this exercise. The terms that are going to be useful to describe where water goes are these four: infiltration, evaporation, drainage, and transpiration. When a water drop enters the soil, that's called infiltration. Once we're in the soil, we have several choices of where to go. The simplest would be just to drain through the hole. Possibly we could evaporate back into the atmosphere and become a gas again. Alternatively, we could be taken up by the roots of the plant, go through its tissue, and then exit through the leaf. As far as the plant is concerned, these two pathways are not very useful. The one that leads to its growth and brings nutrition into the plant is the transpiration, which is that last path we talked about. Let me show you what happens with all three types of pots, and we can compare among them. When we look at a traditional planting pot, we're still losing water through the drainage hole. However, there are a couple of things that we can do to increase the amount of water present. One of them is to have drip irrigation to increase infiltration, so that more of the water you use goes into the soil, as opposed to overhead watering. The other thing is we can look at the evaporation and try to minimize that. That can be done by heavily mulching. In other words, putting dead leaves and straw to prevent evaporation, to slow this down. Let's look now at what can be accomplished by having a water reservoir. For the water reservoir style of pot, you need a container that's deep, and I'm talking about 18 inches. So it won't be your traditional pot. It needs to be something like a rubberneck storage container. So this height, as high as you can get it, I'd recommend 18 inches, which is about 1.5 feet. And all we're going to do here is shut off this drainage. We're not going to drill any holes here. What we're going to do instead is place the drainage holes higher up. You could choose anywhere between 6 to 8 inches of height, and here you can drill holes for water to overflow. And what happens is, when we infiltrate the ground as water drops, we're going to start accumulating. And at the bottom here, you're going to have a water reservoir. Any excess water is going to drain outwards. Now the roots have a way of accessing water. As a raindrop, you're going to have two forces acting on you. One is the familiar force of gravity, pulling you down. And then you also have a water elevator pulling you up, called capillarity. So this zone above the water line is very moist, because capillarity is bringing that water up. The end result is that you'll be able to water this container much less often, in the order of once every 2 weeks, even 3 weeks, depending on how big the plants are and what your weather's like. Now let's have a look at the third type of pot, which is the no drainage one. The no drain pot is going to combine some of the best practices we've seen so far. This is a type of pot that also requires a pretty deep container. We're talking the order of 16 to 18 inches. We will continue mulching the top And the twist on this is that there's no drainage holes. To make this realistic, I'm going to start with a small plant, a young plant that has short roots. And what we're going to do is almost flood this container. We're going to fill it up 2/3 of the way with water. The roots will be able to reach the water at this height. As the plants utilize the water and it leaves the pot through transpiration, the water level is going to drop. Simultaneously, we're going to have root growth. So the plant is going to get proportionately bigger and have a larger root zone. And part of this experiment is to see if the roots will follow down the water so that they have a constant supply of humidity. If this works, then you should be able to water once and then harvest your vegetables 60 to 90 days afterwards. There could be some potential problems. One is if the roots grow into the water layer and suffocate. The top part of the plant uses carbon dioxide to make food. The bottom part, the root, is just like us. It breathes oxygen. So it's important that air spaces exist here. Let me show you a practical example of a pot like this and how you can monitor its progress. The plants on this staircase have been placed into traditional pots. They have 4 drainage holes at the bottom, and here I show you one of them. It's kind of tricky to calibrate the irrigation so that it doesn't overwater. This is the drip irrigation system that I'm using and I mentioned previously. Instead, here we have an example of the second type of pot, the one that has the water reservoir. So about 6 inches off the bottom is a drainage hole. This allows me to water the pot once every 2 to 3 weeks, and the beans that are growing within it are doing very well. And here are 2 examples of no drain pots. You can see that there's mulch on the top. There's not too much because these plants are young, but I'll be adding a deeper layer of mulch. What I filled the container with was about halfway with wood chips and the rest is soil. And what you'll notice is that I've marked the level at time 0 of where the water was. And most of this has been filled with water. There's about 6 inches of space where there's no saturation of water. And I put the date. 1 week has gone by and it really hasn't budged too much. I decided to go with transparent containers so that I could see what's going on, to see how deep the roots are going, what is the water level. Because the containers are transparent, I do see some green algae growing, which I welcome. That's more nutrition for the plants. Do buy high quality containers because in the ones that I purchased, I have sagging on the side, and I suspect this side will be sagging too if these bars were not there. The plant selection I've chosen is these are soybeans. We have some brassicas, bok choy, beans, and these are chickpeas right there. There's a bit of peas in that corner. And here, similar plants, we have 2 squashes. So I look forward to seeing how these plants evolve and let you know if this experiment works. Thank you for your time and have a great time gardening.